So in the words of Gregory W. on LinkedIn, Steve is a creative, versatile, and gifted researcher with the skills, intuition, and enthusiasm to address an impressive variety of scientific problems. In other words, if Steve Crawford and citizen science were presented together on a Venn diagram, there would be an enormous overlap. I first connected with Steve in 2020 at the very beginning of NASA's Open Source Science Initiative, which led to the Year of Open Science in 2023 as both a call to action and a celebration of open science. And it's been beautiful to see what's happened since then. We've invited Steve to speak primarily on open science data management plans, which is a required component of any ROSES proposal. We are expecting that ROSES call to be released very, very soon. He is going to speak to that, but he also has this incredible wealth of information and knowledge and experience around all things open around science. We're going to have plenty of time for your questions, so please make a note. He's joining us on his mobile phone, so he can't see the chat, so save those questions and we'll have a Q&A following his talk. Steve, over to you, and I'm going to be presenting your slides or sharing my screen.
Thank you so much for such a kind and welcoming introduction, Sarah, and it's really great to be here. I know I took a quick peek at the list of participants and saw some familiar names on there, and so it's great to see everyone and great to connect, especially with all the people who I haven't had a chance to connect with yet. And thank you so much for having me come and talk about open science and data management plans, especially related to citizen science. I think I've been working adjacent to citizen science and with many people working in citizen science, and I'm a really big fan of the work that you do. As mentioned, I'm a senior program executive here at NASA. I work as part of the Office of the Chief Science Data Officer, leading the open science implementation. And I'm part of the Science Mission Directorate. And so if you go to the next slide, this is one of my favorite slides here at NASA, showing off all of the range of missions that NASA has. We have a wide range of different missions, which are both on the International Space Station, that are orbiting around Earth, making Earth observations or observations of the solar wind, observations of the sun, of different robots and satellites, which are traveled out to a wide range of planetary bodies around our solar system, along with our astrophysics missions observing our universe. I think I'm always quite, we always have a growing number, but I think it's over 140 of different missions producing NASA data. And this huge wealth of data leads to a wide range of different opportunities to make use of this data. And I wanted to walk through one of the examples because I think it shows this great mix of different ways and different history of data that can be used. And so if we go to the next slide, was just going to actually highlight one of the missions, which is the Solar and Heliospheric Observatory, or SOHO, which is an ESA and NASA mission, which regularly makes observations of the sun and has been producing observations of the sun for almost 20 years now, and observing the corona of the sun and in different wavelengths, and also observing different parts of the sun as well. One of the unexpected, I think, features from the mission, and one of the great things I love about NASA data is the fact for its use in different ways than originally envisioned by the mission. And one of the things that ends up also being observed as part of this is actually comets, which are actually passing very close to the sun. And so in the observations, you'd actually also get these bodies which are moving through and behind or around the sun, which initially was actually very difficult necessarily to detect automatically, but very useful to have actually people take a look at it and be able to detect these sources. And so if you go to the next slide, this is example of one of the great citizen science projects that has been done with NASA data, the Sungrazers project, which used the data from the SOHO project to actually then look at these comets, which are actually passing nearby the sun, and use citizen scientists to actually discover and identify these different objects. And throughout the course of the project, over 5,000 comets discovered orbiting around the sun and passing close to the sun. But then what I really love about, not only do we make the data from our NASA satellites and observatories available, but then making the data available from these projects like the Sungrazer project, which then adds us and allows us to do even more science with it. And so a few years ago, one of the things that we supported from the open source implementation, open science implementation project is a challenge to actually take this data to see if you can create automated algorithms to help detect these comets. And in the next slide, was this challenge that we did with a group called Topcoder, which actually made both the SOHO data available along with the identification of the comets to actually see if people could develop artificial intelligence algorithms that would actually identify these comets orbiting around automatically in the data. And so this is a great combination of, once again, using the data from the satellite combined with data from citizen science projects to see if we can actually develop better algorithms for actually identifying astrophysical or astronomical phenomenon. This project, I think, had over 600 different groups that actually then competed in the challenge to actually create these algorithms. It was actually a two-stage challenge to actually first produce the algorithms and then further refine them with another set of data. And it was using, once again, the data from SOHO combined with the data from the Sungrazer project to actually run this challenge, and shows all the different ways that of making when we make data more accessible, the more science that we can actually do with it. One of the also, even though we actually initially ran this as an AI challenge of people using AI methods, the actual, in the first round, the winning algorithm was actually not even an AI algorithm, but just actually one designed by someone. And so even, which I actually love even more in terms of actually all the different ways we can actually use to actually explore and create algorithms to better enhance the science that we're doing. And so this combination of, and especially when we are looking at open science and basically how we make our data and our scientific results and our other information that we're producing and making it more accessible so more people can access it and use it in different ways. And so if you go to the next slide, this is, really the core question of, a lot of the work that we're trying to actually support here, which is how do we make NASA science more transparent, reusable, and reproducible? And if you click again, this is also kind of the reason and motivation for our open science and data management plans. It's a plan for how to do this, of how to make your science more transparent, reusable, and reproducible as part of a NASA proposal, so that help guide you through your research processes of making it more accessible. And if we go to the next slide, and a lot of things that we often talk about is open science. And so it is also good to make sure that we define open science. And we are using a definition of open science as a collaborative culture enabled by technology that empowers the open sharing of data, information, and knowledge within the scientific community and the wider public to accelerate scientific research and understanding. And so it's really about, as we develop new technologies, as we make things, as we discover better ways to share things with even wider and even easier ways to share things, that we make our data that our scientific data that we produce more accessible and more available to an even wider community in the hopes of accelerating scientific research and understanding. And how we're doing that on the next slide is helping to actually plan for it through open science and data management plans. And so one of our requirements, starting with ROSES 23, and ROSES are our main omnibus solicitation for grants for NASA science. Our research opportunities in space and earth science is the primary solicitation for our research. Most ROSES programs already require an open source and data management plan as part of their development. And OSDMPs basically give you a chance to answer the question of basically how you'll make your publications be publicly accessible, what data will be used and produced and made accessible, and what software will be produced and made accessible. We've actually made available a common SND template and additional resources for the community to actually complete your creation of your open science and data management plan. And that's all available on the ROSES OSDMP page, which is linked to the slide. I have asked Sarah to make sure to share these slides with everyone so that you do have these resources. But these are also links to all of this can also be found on our open science pages on the NASA website. And so if you go to the next page, I'll go into a little bit more detail about what some of the requirements are and how we actually hope that our scientific information will be shared. One of the things we'd like to make sure is that our scientific data should be fair, findable, accessible, interoperable, and reusable. And that's made publicly available with a clear, open, and accessible data license, no later than the time of publication, and that it's made citable. We don't expect proposals to include long-term archiving of the data. That's services that NASA will provide or will provide options for you to make your data available, and I'll talk about some of those. For research software, for software that's developed as part of the publication, that we want to make sure that's made available. We know nowadays that software is such a key part of the science which is done by in Earth and space science that releasing that software really helps the science to be more reproducible and reusable. We also likewise don't expect any long-term maintenance or long-term support for that software as part of a proposal. And that we expect to provide options for how that can be archived in the long term, which is many of those are actually happening automatically. For publications, we do expect publications as if you produce a peer accepted publication to be deposited in NASA's repository and made publicly available without any embargo. We also support publishing as open access, and I'll talk about this a little bit further. But we also, the open science activities will be considered as part of the reviews of your proposal. They're included in the merit assessment of the proposal. And so these are things, especially as you're sharing them, can be part of the assessment of the proposal. Most proposals do require an open science and data management plan. Although if you're not producing any new software or you're not planning to have any publications or produce new data, then you can actually just simply state that no new data or no new software will be produced. But we do expect most proposals and scientific activities to at least produce new data or new publications. If we go to the next slide, I can go into a little bit more detail about the publications. And so as part of the OSDMP submitted to a proposal, it describes the types of publications that are expected to be produced from the activities, how they will be made available. And so it's really about how you'll be sharing your results. Will they be in peer-reviewed papers, conference proceedings, blog posts, and how will the people be able to access them? Reasonable costs for publishing as open access can be included in your budget. And we also encourage posting papers as preprints. And so making them available on platforms like Archive or other similar platforms where they're actually made available even before they're published or made, or even before they're published. We really do, want the publications to be made as openly as available and as made as widely as possible. One of the reasons we do support the cost for publishing as open access. And so I think one of the things, especially if you're writing proposals or working in citizen science and for citizen science projects, is how will those, especially, thinking about how those who participated in it will be able to see the results of their work. And also thinking about how will they be credited. Will they be co-authors on the paper, or will they be acknowledged in a different way as part of the work which is being done? And so these are some of the things that you can address as part of the Open Science Data Management Plan. And it's really about, once again, how you plan your project and about how you're making it more accessible. If we go to the next slide, we can talk a little bit about the data management plans and what's included in there. And so in the data management plans, it's really about expected data types, formats, volumes, and standards. So what kind of data you'll be managing as part of your project, how that data will eventually be archived and made accessible, and also what data might be exempt for data sharing requirements. Maybe you are actually dealing in something which has personal information, or if you're involved with a project with other sensitive information, you may not want to share that publicly, or in a way that it might be, that some of that information might be protected. And so how you might protect that information is something to include in your data management plan. In the next slide, we have some examples of where to share the data. There already exist many resources for sharing Earth and space science data. While some of these are actually NASA repositories, some of them, while most NASA data repositories are focused on mission data, some of them do accept research-generated data, especially when it is related to their mission data. And so if you are producing citizen science projects, which are a follow-up to a mission data, very many mission archives will be actually interested in hosting that data. There's also domain-specific archives, NASA data repositories as well, which are related to the subject matter that, a specific subject matter or a specific domain. These good examples, these are repositories like GeneLab or Nexi, which is focused on exoplanets. And there's, other data repositories like MAST or Oak Ridge National Labs data DAC, which are focused more on mission data, but also accept community contributed projects when it's related to that mission data. For domain, there's also non-NASA repositories, which are domain specific, which might be the best place to store your data. For example, other government agencies like USGS might be an example. There's the CDS, which stores general astronomy data, and also a wide range of different repositories in the planetary data ecosystem, which all might be best places or the best place to make your data most widely accessible. There's also general repositories, and generalist repositories provide general sharing data for basically scientific data. Examples are, for example, Zenodo or OSF, the Open Science Framework, Dryad, Figshare, and Dataverse. And these basically usually have either both free and paid versions for actually how the data, both long-term storage and how that data may be shared. These are actually very good options if there's not necessarily a specific place or you have very general data in nature. And so these are all different very good options and places to share the data. In the next slide, we talk a little bit about software and what would be actually included in the software management plans. These are, for example, expected software to be developed, software archiving and accessibility of that software that's developed, and descriptions of software that are exempt from software sharing requirements. If you're using specific software as part of the program, you might want to also describe it as part of the software management plan, even if it's actually software that you're using and not needing to develop. And so I imagine, for example, for citizen science projects, that might be whether or not you're using Zooniverse, or if you're standing up another platform to make use and run your project, that's probably something that you'd want to describe as part of the software management plan. We do require that scientifically useful software that is developed under the award is expected to be released if there are no under restrictions, either with the publication that's associated with or at the end of the award. Enhancements of existing software are not required to be released, but this is encouraged. There are no limitations on the use of software or expectation of release of software that is used. And so We don't have expectations on you must use open source software or you must use a specific type of software unless that's explicitly mentioned in the solicitation itself. But that, in general, we want you to use the software that you're most familiar with that would make your project a success. And you're probably the ones most experience with actually expecting, or understanding what you need to do and get done your project successfully. And so that's a quick overview of our the different components of a open science and data management plan. I'm also, once we get to the questions, I'm happy to go into more detail or specific sections about, any specific questions that you have. But I wanted to also mention some of our additional resources that, we actually have, and on the next slide and the following slides of kind of some of the further support, especially from the Office of the Chief Science Data Officer, that we're hoping to provide to help actually enable your projects. The OCSDO was actually set up about 4 years ago to actually help enable groundbreaking discoveries by expanding the availability and utility of NASA scientific data. This was an outcome of a strategy that was released in December 2019 called the Strategy for Data Management and Computing for Groundbreaking Science. The OCSDO provides leadership across NASA's Science Mission Directorate to make scientific processes more efficient through data and computing systems, innovative data science techniques, and transparent open science practices. And so on the next slide, we walk through some of the different areas that we're actually working on to actually help enable. And these include core data and computing services, continuously evolving our data and computing systems for efficiency, sustainability, security, and scientific integrity. These are actually hoping to provide kind of core services and core capabilities for people to actually build their scientific platforms and scientific resources on top of. And so how we provide the data and computing and in an efficient manner and in providing resources for how people are doing their science. Our data science and innovation focus is really about advancing scientific discovery through innovative applications and partnerships in data science, advanced analytics, and artificial intelligence. This is a group that is really focused on how we actually lead and use some of the latest data science tools, including artificial intelligence, to help advance our science. Some of the won't go into the details on this, but some of the exciting things that they've done is foundational artificial intelligence models, which actually provide greater access to some of our data and ability to provide and develop new tools that actually build off of a wide range of NASA data. And then, as mentioned at the start, our overall open science implementation to support transparent, trustworthy, and reproducible science through open science tools, practices, and guidance. And so the open science implementation provides our policy support, and so our help in implementation of the open science and data management plan, but also provides grants and opportunities supporting open science as well. If we go to the next slide, we have some of the examples of some of the tools that we're actually providing to help actually advance and provide more access to the data and scientific results that NASA produces. One of the tools that we've released last year was in collaboration with the NASA ADS service. For those who are familiar with that, is a Science Explorer, is a literature-based digital library designed to revolutionize how science resources are found, accessed, and utilized. It's an expansion of the Astrophysics Data Service, which already provides search of astronomy-related publications, and it's been expanding that capability to include all of Earth and space science as well. And so if you're familiar with ADS, Science Explorer will be very familiar with you, very familiar to you. It provides basically a search through all of publications, not just NASA's, related to Earth and space science. And so it's a great resource to take a look at and discover related publications and related science to different topics. We've also released the NASA Science Discovery Engine. This actually provides search across all of NASA data and all of NASA scientific data. And so this is a great resource for providing search across different data sets and different resources for discovery of a wide range of related data and connecting you to our different data repositories, providing search for that. Likewise, we've also released the Science Data Portal, which actually provides one place, one website to actually be able to provide search for different data repositories and connecting you to the wide range of different data repositories and activities. We do link to our citizen science tools on there, and along with all the different data repositories in our different fields, along with a selection of different cross-divisional repositories as well. We're always looking to grow this, and so add more resources and continue adding more resources to it to actually enable and make it as easy as possible to discover NASA data. If we, because we do actually have a lot of NASA data, and on the next slide, kind of have a summary of some of the data usage by SMD. The different NASA data archives have over 10 million unique users in fiscal 23, currently has over 140 petabytes of data, which is available to that. I think it's actually almost even 100 of the petabytes is available on the cloud as well. We typically actually ingest around 50 petabytes of data per year. And with by fiscal 29, expecting to have over 500 petabytes of data. And this is spread across about 1.5 billion total files. And so there's a lot of great data which can be used there, both for a wide range of science projects and citizen science projects as well. And if we go to the next slide, we have also what some of our opportunities as well. Each of the divisions have their own calls to help support scientific activities. But we have a couple, especially that the Office of the Chief Science Data Officer support, along with some coming from our science engagement branch as well to support citizen science. And so some of these are currently open in ROSES, and others will be open in ROSES 25. But these include supporting our workshops and conferences through our TWISC, our Topical Workshops, Symposiums, and Conferences call. For OCSDO, we do support activities like hackathons or data challenges. And so we're always interested in opportunities like that. We support general open source software and tools through our open source tools, frameworks, and libraries. It's through this call that we support projects like NumPy and SciPy, along with things like AstroPy, SunPy, and Archive. There's also the development of citizen science projects calls with F9, and if Mark is on afterwards, he will probably be able to talk a lot more detail about that. We also have two additional calls for supporting. One is supporting innovative new ways to support open science. This is our high priority open source science calls. These are basically 1-year grants to kind of provide seed funding for about 100K to support innovative open science projects. And we support a wide range of different things. And so if you are interested in developing, say, a new citizen science tool or a new way to make the data or software more accessible, that would be definitely a very relevant call, and encourage you to take a look at that. For existing proposals, we also have a supplement for open science and cloud computing. And so if you have an existing NASA proposal and there is additional activities that would make your data or your science more accessible, take a look at that. Or if you need funding and support for cloud computing, we actually have cloud credits that we can actually provide. And so if you do actually have a need for cloud computing, or if you're interested in trying to shift your workflow to cloud computing, we can actually help support that and would be very interested in talking about that. On the final two slides, we have some resources for researchers. This is actually just a list of some of the different places where there's more information. Once again, for OSDMPs, I would check out the ROSES Open Science and Data Management Plan page, where we also link to the new SMD template for OSDMPs. But we also have the SMD Scientific Information webpage, which does have FAQ, frequently asked questions, on related to our open science policy. We also have, if you do actually have any questions directly related to open science, you're always welcome to email us at the hq-fmd-sbd41@mail.nasa.gov. We're always happy to answer your questions. We also have a general guidance for open source science guidance for researchers. This really goes into some more of the how to implement the policy, like different places to make your data accessible, or different aspects on how to make your software open source. And so this is definitely additional guidance, which is there and available. This is very general. In addition, each division has made their division-specific guidance, which is very much related to them. Might talk about specific repositories to share certain types of material, might talk about different expectations or different places to make your information more accessible. We've also had a guidance for reviewers for OSDMPs. So for people, when you're serving on a panel and are interested in reviewing proposals and how to review OSDMPs, we have guidance available for that. It is currently paused as we provide a number of updates to both the content and the interface for it, but we also have our Open Science 101 course. And so if a lot of this was actually very new to you, or some of it was maybe some of the concepts were things you hadn't encountered before, I'd really encourage you to take the Open Science 101 course once it's made available again. And the best way to find out about that is clicking on and when it'll be available again, along with other updates, is on our last slide here. So if you go to the last slide, we do have a monthly newsletter on NASA Open Science. And so if you would actually like to hear more about both different opportunities or different aspects, I definitely encourage you to sign up for the newsletter. But I'd also like to encourage you, if you're starting a new open science project or a new citizen science project, let us know about it. If it's a NASA project, we would love to advertise it in our newsletter. We have over 10,000 people who get this newsletter once a month, and we'd love to share it with them, because I'm sure a lot of them would be very interested in potentially participating in your projects. And so definitely, hopefully you can also think about this both as a way to hear about the latest information and latest NASA open science updates, but also a way for you to potentially share your updates as well with this community, especially if you have new citizen science projects that are started. And so that's my slides. I wanted to keep them kind of short because I wanted to leave plenty of time for questions, and would love to actually get into the questions that you have. So thank you very much for listening.
Thank you. That was terrific. And I made a note about the newsletter because we do like to share about the citizen science projects, and maybe you and Mark and I can coordinate the announcement of new projects. It would be terrific to see them in your newsletter.
That'd be great.
Thanks for your patience as I was forwarding all the slides. I was scrambling and taking all these notes too, because I think there's so much to talk about. So I am going to put us back in more of a sharing mode. I have a whole pile of questions, but I bet other people do too. But just to get us going. Well, does anyone have any questions?
I see there's one in the chat.
Go for it.
Yeah, so I was just going to say, the one question in the chat was, are there preferred formats? For data, and this is actually one of the things we talk a little bit about in the open science for guidance for researchers, and so that'll be a good reference. For data, we want the data to be, so basically for preferred formats, or actually it's even required, is that the formats are non-proprietary, that they're open, and that they're machine readable. For specific formats, we don't necessarily say, at the SMD level, we don't necessarily say or recommend any one specific format or another, because we know that's very domain specific. But what we do require the formats to be open, non-proprietary, and machine readable. But within different domains, there's a lot of great examples of different formats that meet those requirements.
Great. I know we've got a lot of people from the science activation community on this call, and one of the things that's always in my mind as we talk about these open science, making data more available. It's like, well, you need to have people who know what to do with those data and how to navigate those spaces and how to go about creating a project or asking a question and finding an answer. And I'm wondering if your group has any existing relationships with other parts of NASA that do more of that kind of education and training, in addition to what was TOPS and is now Open Science 101. If you can talk a little bit about what's in place and what you'd love to see happen in the future.
Yeah, I mean, we work very closely with Lynn Chambers, who's in the science engagement branch, and along with Nancy Serby in Earth Science as well. I think there's a lot of great. We actually had a talk from a number of the science activation groups 2 weeks ago here at headquarters, and hearing great things about an open space and cosmic stories, and one more which I'm going to forget off the top of my head right now. But they, I think, are really doing fantastic jobs of making data more available and more accessible. And so also groups we love to highlight. One of the things that we, along with our Open Science 101, one of the things, and I hope these actually start becoming, more available and hope, kind of one of these of hopefully there's more information soon. We also did fund the development of data science curriculums as well. These are basically 10 projects, and they've been developing many of these open as Python notebooks or Jupyter notebooks, or that are made available to actually show how to make use of NASA data as well. Some of them have also been making them available on, I think it's Canvas as well. And I'll see if I can find the link to it. There's a great example done by one of the groups working on GeneLab, where it does actually step you through how to actually make use of the NASA data, and also kind of make use of AI models, along with working on that GeneLab data, which is experiments from the International Space Station. And we have a number of others which are on exoplanets, on a number on Earth science, along with planetary science and heliophysics as well. And so hopefully once those are ready, can share those with you, as well as what we kind of refer to as our science core of these kind of notebooks and resources to actually see how to use NASA data. And then with our science activation groups focusing, on that wider and broader community, and how to make data more accessible there as well.
I think that GeneLab course is an online course. Is it? I think that's one of the things that I'm about to add to our we have a PDF that we maintain of citizen science projects that have associated learning resources, and that's coming out of one of the newer projects that we're bringing on board, or newer project that we're connecting with. The project itself isn't new, it's new to the citizen science portfolio. So it's nice to hear that connection, but we should also keep in touch about those kinds of educational resources. If we can make them available through our community, maybe we can get more attention to this work. One more follow-up question about that. Your description of the F.15 opportunities, is that something, could someone make a proposal to do some kind of an educational or develop educational resources that would help more people access open science? Would that be something that would be considered in that call, or qualifying?
For ROSES 24, which is currently still open, it's open until March 13th. That is actually something we included there. We are thinking about how to for future years, we're thinking about how to best solicit for that. But under the Roses 24, which is still currently open, that is available there.
Excellent. Hi, do you have a question?
Yeah, hi. Hi, Steve. Thanks for the presentation. I have kind of a question regarding when we prepare this open science and this document, data management document. So if we, in a NASA proposal, if we say we use some commercial satellite image, that image, for my understanding, is, cannot distribute publicly, although we can use it in our research. So in terms of that kind of data, I wonder how can we address in the data management plan?
Yeah, that's a
Thank you.
great question. And that's one of the things that we, kind of actually say of, we know not all data can be open. It'd be nice if all data was open, but there is things like intellectual property. There are different licenses and restrictions on data. And the
Yes.
important thing is to describe that as part of your open science and data management plan.
Oh,
So
okay.
if you don't have the rights to share the data, you can, we still want you to do the science.
Yeah.
And we want you to, still be able to actually share possibly, describe what you can share, and describe what you can't share. And that's why it's there. It's, you, as long as there's a legitimate reason for not being able to share it, like, for example, the license of the data does not allow you to share the underlying data. But usually it does allow you to share the derived product of it. And so, being able to actually describe, we won't share the underlying data, but the derived product we will share.
Okay.
Or whatever is allowed by the license of the data. And that, that is allowed. You're allowed to use restricted data. And it's just describing it as part of that OSDMP.
Okay, I understand. Thank you.
Other questions? I'm going to keep asking them if nobody has one. So here's another. I love this move that NASA is making towards openness. And the researcher in me wants to know, are there any ways that your group is kind of setting itself up to measure the impact of this move towards openness on NASA's overall productivity? I would imagine that there's measurable added value of opening up these data sets, but have you identified metrics that you're tracking to start documenting that?
Yeah, so we had a fantastic intern last year, Becca Mickelson, who actually went and did a kind of a review of 2023 publications to actually see how open they were. And she actually presented the results at AGU in December. And so I can actually add that slide to the backup material.
Great.
Let's see if I can actually do it quickly, and then you could actually even bring it up and share it. But basically, what we did was basically reviewed through, and once again, the 23 publications weren't required to be open yet. There wasn't any requirement, but we wanted to see how our communities were already doing. And already from that, that initial, actually, if this is sometimes the wonderful thing about, if you actually want to bring up my talk again.
Okay.
And
refresh.
Yeah, refresh. And if you go to the last slide, hopefully it will be in there.
That's the last slide that's showing up. Maybe I need to refresh again.
Keep going.
There's nothing there. Let me get out of slideshow mode.
Oh, I think I know. I think I know the problem, because it's Give me.
You're all giving a nice preview of the slides that you'll have access to later. And what a great sprinkling of resources you've got throughout this. It's really going to be useful, I think, to our community, especially as we start responding to Rose's 25 when we see it.
Could you just try and reload that page? Oh, that's weird. It's not showing up. Okay, I will just explain it. And sorry, but I'll try and make sure it's added in the version that I'll send to you just so you have access to it.
Great.
But basically what Becca did was kind of did a spot sampling of 30 papers in each division and assess basically how open the data was and how open the software was. And what we actually already found is that most people are already doing open science than not. So most papers were already being published as open access, or there's an open access available version of it. Most people were already either using public data or sharing their data in some format. And a lot of people were also sharing their software already as well. The software wasn't quite as common as the data, but it already is, being shared by many people already as well. There was some variety between the different divisions. Earth science was by far the one that was already most open, within some of the space science areas not being quite as far along, but there was a really good mix, and plenty of evidence in each division of people already being fully open with their data and software and their publications. So at least right now, we're hoping to do something similar kind of every year to actually see how it progresses along, along with looking with other metrics, for how people are looking at. The one thing I do want to emphasize is we're looking at this at a general level. We want to see how the overall community is. We're not interested we have no plans right now and I certainly don't have enough resources to actually look at an individual level. And so it's not something we're looking at like enforcement. What really want to see is, how the community is adopting it. And so.
Yeah, so I hear you describing some good ways of tracking how the community is beginning to use these practices, but have you seen like a jump in publications, or is there a way that you can track publications that people are making because they all of a sudden had access to these data and doing research that would not have been done if the data were not open?
So there is, so in terms of that, there has been some good publications and research done on it. Particularly, I actually think about the one I actually particularly think, just because being an astronomer and the background in there. Oh, I completely forgot. But MAST and Hubble did actually look at the Hubble data and the Hubble archive and how much it's actually reused. And nowadays, actually more papers, I think they did cross the threshold of each year, more papers make use of older Hubble data than which are being produced by the current observations. And so the archive, the Hubble archive itself is actually more productive than yearly observations. In Earth sciences, I think, I'm trying now, I'm gonna get the numbers wrong, but something like they have 600,000 people, I want to say, users, and I'm now trying to remember if it's each month or each year. But either way, there's a much, much greater number of people who are making use of the data than the people who are working on the missions and producing the data. And so, we do have other evidence of like how people are making reuse of the data. And we also really always love to tell stories of how people are doing it. So that's also one of the things, always love to highlight as well.
Speaking of old data, a question that often comes up from our scientists who are leading projects is a question about archiving and what kind of support NASA can provide for archiving data sets. And it seems that there's quite a lot of variation across the divisions. Do you have a crystal ball that can kind of look out and see where the divisions are moving and what, are they all going towards a similar model and serving the projects that they're funding in a similar way, or is it always going to say different, or what can you tell us about that?
Yeah, I mean, I think, one of the things we've at least, the OCSDO has committed to is basically providing a long-term solution for archiving our research data. So the data coming out of our research projects and other things. This is likely to be a mix of, and as it is currently, a mix of NASA-specific repositories, domain-specific repositories, and generalist repositories. And so, we have some great examples from the different divisions of, I'll mention things like GeneLab and Nexi and the NASA Extragalactic Database as good examples of how domain-specific information has been made available. There's also things like the Hubble Legacy Archive, and so we have lots of great examples. There are also different considerations in terms of cost and funding and in terms of what the expectations from different communities as well. So there's not likely to be like one single solution, but probably continue to be this mix of solutions and different options. And especially one of the things I think has been really positive is we do have our different divisions learning from each other a lot more. And so we do actually see, the best practices from different places being picked up by the different groups.
Yeah, and it's exciting to see some of those other projects you described that really help serve as search engines for finding data, no matter what repository it's in. It seems like a really powerful move. And I hadn't heard of a lot of those, the free and low cost general databases that might be available. And those are a great resource for us to share with people who are concerned, especially about the costs of long-term data storage.
Yeah.
Great. We are approaching the end of our hour. Anyone else want to put a question on record? I'm gonna go back to my.
I have one more question, sorry.
Go ahead.
Yeah.
So I just curious, I saw in a slide there's a kind of slide saying what open science will NASA fund, and there is one category is F7. It says open source tools, framework, and libraries. So I'm curious about these open source tools. So I mean, how big enough this kind of tools can be considered as kind of the scope of the tools, how like what kind of size of the for example satellite image need to process or this kind of
Yeah.
thing. Yeah.
So our OSTFL call, it's
Mhm.
so it's one we host every 3 years.
Okay.
But we do support a range of projects. So basically some of the grants are for 50,000 a year, and some are closer to $500,000 per year. And we support both projects which are like NumPy and SciPy archive.
I see.
But then we also support really domain specific projects as well, like in terms of that are particular to one domain or even one field within a domain. And so it is a fairly competitive call. We don't have a huge amount of funding. Our total budget for year is around $3 million. But we really do actually accept a wide range of projects. And the idea behind this is actually it's actually very unique because we actually don't ask for anything, not to say you don't need to be innovative for this, but what we prioritize is sustainability. So what we really actually say, like, so things that are widely used in your community or in your area. And what's the support you need to be sustainable? And so for some people, that's really small. For other projects, it's big. And so we do have a kind of a wide range of different support there.
Okay, got it. Thank you.
Yeah. All right.
We've got a question in the chat, maybe. Oh, no, just an appreciation. Thank you, Melanie. It's great to be here with all of you. And let's bring the formal part of this to a close. Steve, thanks for that great presentation and for sharing your slides. I think is going to be a really useful, lasting resource for our community. So really appreciate you being here with us. Thanks.
Well, thank you so much.